This idea of rationalising the denominator turns out to be a rather important function. So something like this. By the way, if you come up with an answer that's 4 on root 2, how many people would just leave it as 4 on root 2? So only one of us? Yeah, that one of us is me. All right? 4 on root 2 is a perfectly fine answer. This obsession we have with rationalising the denominator. The only reason you rationalise the denominator is for the sake of comparison. Because you can only add, subtract or compare fractions when the denominator is the same. So we like to make the denominator a rational number to do that. But otherwise, like for instance, let's jump ahead to trig. Hopefully you'll remember the answer to this one. What's the sine of 45 degrees? Can anyone tell me the sine of 45 degrees? Sorry, what was that?
1 on root 2.
Why did you leave it as 1 on root 2? There's my point. We're quite happy to leave the sine of 45 as 1 on root 2. So where's this obsession of rationalising the denominator come from? So let's say we really only rationalise the denominator if we're then going to do something with it. If we're just trying to find the value of something, well, 4 on root 2 is a perfectly fine answer. But if I do need to rationalise it, we want to turn it into a rational number, so the simplest way is just to multiply it by the same surd. So root 2, but I can't just change the question, so I've got to multiply the top by root 2 as well. 4 root 2 on 2, which in this case cancels, and we get 2 root 2. So something like that, you don't have to multiply by 2 root 5, of course, you only have to multiply by the surd. So we only have to multiply by the root 5. And we get 3 root 5 on 10. Of course, had you have multiplied by 2 root 5, you're still going to get the right answer, but it means you're going to have to do some simplification to your answer. More commonly, we see ones where there's 2 terms in the denominator. Then we multiply by the conjugate. Because with the conjugate, we'll get the difference of 2 squares. We'll create a rational number. So we get 2 minus 1, which is, of course, 1. So 3 root 2 plus 3. Be real careful. It's so easy to go root 2 times root 2 is 4 and things like that. So just be real careful with those. 2 minus root 3. That's a classic question. So the top of the fraction, we get the perfect square. Bottom of the fraction, we get the difference of 2 squares. Once again, it's ended up with 1. Of course, it doesn't always end up with 1. 7 plus 4 root 3. Okay, so we'll add the rationalising the denominator to our list of questions so we can spend the day recapping our surds.